Here we have a pneumatic system. It is a pneumatic system because there is air or a gas inside it. If there were liquid inside, it would have been an hydraulic system because of the liquid or water that's inside. This system consists of a connecting tube, 2 cylinders, and 2 pistons. In pneumatics and hydraulics, we call the switch the master. And then whichever the switch or the master moves is called the slave. So I'm going to make sure that I only press the master. I'm not going to touch the piston of the slave so that I can demonstrate how that works. Now, remember we said that levers and hydraulics and pneumatics are similar in that they both can create a mechanical advantage. Now, what that means is that they can either multiply or divide the force. In other words, they can the master can make the slave move in a more powerful way or with more distance, but it cannot have both. So it's either going to have more distance or more power, but it's not going to have more distance and more power. In other words, it's a trade-off. You pay for distance with power or you pay for power with distance. Okay, so here we have got, we've got 2 syringes that are the exact same size. They are both 5 milliliter syringes. Okay. You'll see when I press there's going to be a slight delay because, as we know, air is compressible. So it needs to compress first before the slave can follow the master. But have a look now when I press here. Compare the 2 pistons, compare the movement. Do you see a significant difference in the distance that each of them is taking? Or does it almost look the same? If the distance is the same, do you think that the force will be the same? Or do you think the force will be more or less? Okay, I'm now going to introduce a different system. Right. In this system, I have a 5 milliliter master and a 10 milliliter slave. So in other words, the master is much smaller than the slave. Let's look what happens when I have a small master that is controlling a big slave. I want you to compare the distance that the 2 pistons travel. Okay. Do you think the master traveled more than the slave? When I press in the master traveled this far, whereas the slave only traveled this far. So the slave does not travel as far as the master does. In fact, the master started completely extended. But when the slave followed, it was not extended completely. So therefore, there is less distance. And if there is less distance, there is going to be more force. So if you are using a small master with a big slave, you will have a mechanical advantage. I always, in my mind, have a picture of a mouse lifting a elephant with his little finger, because that's the effect that this can have. Right, now, if I were to switch it around, and I were to make the master the 10 milliliters and the slave the 5 milliliters. In other words, big master, small slave. Do you think I'm going to get more power in the end, or will I get more distance? Let's have a look. Right, have a look at how far the master travels. The input distance compared to the output distance of the slave. Which one traveled further? Do you see that the slave had to travel much further? So there's more distance. Distance is increased in the output. So distance is more. And if distance is more, it goes without saying that that there will be a mechanical disadvantage because the power will have decreased.